Next award ceremony of today is a thesis award. This year, EPMA received a total of 18 doctorates and masters for the competition. So the jury had the hard task to select one doctorate thesis and one master thesis. Award is sponsored by Hilti. Doctorate awardee will receive a €1,000 check and master awardee €500. Both awardees are granted a free full access to attend the whole European Congress exhibition as a courtesy from EPMA. Counterpart being they have to present their work in 3 minutes. In the category doctorate, the award is given to Dr. Bruno Guimarães for his thesis. Bruno is graduated from the University of Minot in 2018 with a master's degree in material engineering and in 2024 with a PhD degree in mechanical engineering. Currently, he works at Palbit as R&D engineer and R&D project manager. His investigation is focused on the development of novel solutions for the cutting tools industry. He published 19 papers in ISI Web of Science journals, supervised 2 master theses, and participated in several national and international conferences. He is also a member of the research group Center for Micro-Electromechanical Systems. Please, you have the floor for 3 minutes.
Thank you. Good morning, everyone. First, I would like to thank EPMA and Hilti for this award. It's a great honor for me to be here today. Also, I'd like to thank my supervisors and Palbit and Siemens for all the support during my PhD that is entitled Multifunctional Cemented Carbide Cutting Tool, a Multi-Material Engineering Design. The cutting tools industry is facing several challenges in recent years, namely the increasing use of difficult-to-machine materials that generate a lot of temperature during the machining process. Also, the necessity to reduce production costs and increase production rates, as well as the increasing global competition in this industry. So, the goal of this PhD was to develop multifunctional, multi-material solutions for cemented carbide cutting tools with a new level of functionality, adaptability, and tailorability. Here, 2 different solutions are developed, one to measure the cutting temperature in real time, and the other to reduce the cutting temperature. So, to measure the cutting temperature, a concept design as this was developed. A K-type thermocouple was embedded in the rack face of the cutting insert. For this, a hybrid manufacturing process was used. First, laser surface modification to produce a microgroove, and then multi-material laser powder bed fusion to fabricate the 3D printed thermocouple in that produced microgroove. As we can see here, we produced a smart cutting tool that matches the defined design and is able to measure cutting temperature in real time during machining process. In this case, we have here an example during turning of IZ316L stainless steel. Regarding the reduction of the cutting temperature during the machining process, here we use laser surface modification of press cutting tools. This is a process in which we perform the surface modification in the green state. This is before sintering in order to not affect the integrity and properties of the substrate. To enhance the heat extraction ability of these tools, cross-sectional micropatterns were produced in the rack face, leading to a 52% tool area reduction during the machining process, which is a significant enhancement in the machining process. Finally, I'd like to invite you to my presentation on Wednesday afternoon about the use of these smart cutting tools to measure cutting temperature in real time. Thank you.
Thank you. Now the next award will be given in the category Master to Alessandro De Nardi. Alessandro obtained his bachelor's degree in mechatronic engineering at University of Trento, where he completed his thesis supervised by Professor Alberto Molinari. He then moved to Politecnico di Torino, becoming an active member of the Formula Student team, and conducted his master thesis at IMDEA Materials. After a year at Avio Aero, General Electric Aerospace Company, he is now pursuing a PhD on nickel-based superalloys at the University of Oxford under the supervision of Professor Grant, Dr. Liotti, and Professor Reed. Please, Alessandro, you have the floor for 3 minutes.
Thank you very much for your warm welcome and for this prestigious award. I would like to thank a few people. At first, my partner, Anna, my family and friends for their support, and also my supervisors, Professor José Manuel Torralba, Professor Marco Actis Grande, and Dr. Ad Mohammad Sadeh. Our research is focused on cobalt-nickel-based high-entropy superalloys. But actually, what do we mean with that? I would like to spend a few words on this since it's a quite cutting-edge topic. We know that nickel-based superalloys are the state-of-the-art in terms of high-temperature applications. They show high resistance at high temperature due to gamma-prime precipitation hardening. Cobalt-based superalloys are gaining interest since in 2006 it was demonstrated that also this kind of superalloys can be strengthened by precipitation hardening. So why not developing a cobalt-nickel superalloy with a very strong solid solution as a matrix and with gamma prime with an improved solvus temperature? On the other side, we know that high entropy and high entropy alloys have a series of advantages. For example, mechanical strength, thermal stability, microstructural stability, and many more. So why not taking into account high entropy principles in tailoring the composition of a novel cobalt-nickel superalloy? We decided for powder metallurgy in order to enable the material to show its unique properties. We started from gas-atomized powder. We studied both sintering and additive manufacturing. We understood which defects were forming and why in order to avoid them. And on the almost zero defect material, we performed also any treatment optimization. Since it's a very novel topic and we didn't have much works to compare with. So we ended up in a material with a gamma-gamma prime microstructure and with no embrittling phases. I'm thinking about mole, AVES, TCP phases, etc. And also with a high yield strength up to more than 800 degrees C. So these are only initial results, but I would say are very promising. Thank you for this award and for your kind attention.
Thank you. Next award will be given by Ralph Karlström. Fellowship and DSA Awards.
Okay, the Fellowship Award was created back in 2017 to recognize people from the scientific, academic area was contributing to the well-being of EPMA and the industry. And the winner of the award, of the Fellowship Award, this time is is Professor Christian Giel Meyer. So, Christian, if you please come forward. So, congratulations to start with. Thank you. So some word about your background then. You took your master and your PhD from the Technical University in Vienna, and you got your PhD back in 2000, so some years ago. And your supervisor at that time was another well-known person for us, Professor Herbert Dunninger. And then you have worked at the university for most of your time. You became the assistant professor back in 2017, and you became professor back in 2022. And most of the time, it looks like you worked specialized on sintering.
Yes.
And you got some nice awards during the time. First for your PhD work there was an award from MIBA, and that was for promotion of technical science. And it was for your work on manufacturing of PM parts by optimized sintering. And then back in 27, you got another impressive award. So it's the German Resource Efficiency Award for a product that you were running called efficient production of hard magnets based on rare earth methods. And coming then over to EPMA, you have supported EPMA for a long time, primarily focused on the summer school, and starting as a lecturer, and now you are a coordinator together with Professor Marcos Actis-Grandi. And the summer school is really a success. I think Lionel touched upon it here earlier today. That is a way sort of to school and train future people into this area. And I think for the 2 last years, we have had between 90 to 100 applicants, but we have only 60 seats. So it's a very well-visited education, and very important, I think, for us as an industry in the future. So thank you very much for the good work. And, yeah.
First, I feel really, really honored to get this award. I want to thank some people, especially for sure EPMA, for choosing me for this award. And I took a look at all the fellows awarded till 2017, and being named among these big men and women of PM feels really great, you know. For sure, I want to thank my wife and my lovely kids for their ongoing support and love, and not to forget my parents and my sister. And finally, I have to mention some special people. Without them, I wouldn't have been here today. Unfortunately, the most important one is not able to be with us today. My teacher, supervisor of my thesis and doctoral father, supporter of my whole university career, and friend, Herbert Dunninger. For sure, my team at Chemical Technology at TU Wien, all the professors there, and the former and actual students at TU Wien, I had the honor to support and to supervise. Sorry, I'm not able to mention all the people out there who became friends over the years, but a few have to be named. All the Höganäs chair crew, José Manuel Torralba, Alberto Molinari, Eva Dudrova, Sven Bengtsson, and some others. And finally, my mate from the summer school, although he's still making jokes about my chemistry work in PM, Marco Aktiskamde. Thank you all.
Okay, so I'm honored to present the award, Christian. Right, and then we're moving over to the Distinguished Service Award. And this award was created back in 1998, so a long time ago. And it was there in order to recognize again then people who have contributed to the well-being of EPMA and also the industry in the end. And this award is elected by the EPMA Council that consists of around 20 persons. And the winner this time of the award is so it's Mrs. Caroline Larsson from Höganäs. Okay, Caroline. Just for the people here to know a little bit more about your background. So you got a master degree in Metallurgy and Material Science from the Royal Institute of Technology in Stockholm. And after that you joined Höganäs, more or less direct, of course. And then you spent your time working in lots of different types of activities. So in product development, process development, business management, sales, strategic work. I think you've been involved in all launches of new products for present sinter materials. And you also worked with surface coating materials, soft magnet materials, so a lot. A lot. Right, and you like to work with teams, of course, with colleagues, and a lot with customer. So you've been traveling a lot in your work over the years. And in the 90s, you were supporting our activities in Japan. So you spent a lot of time there together with customers, which was quite unique for a female in this area. And in back in the beginning of this century, then you supported our work over in US, so traveling a lot in the US market as well. And you are, on your private time, you enjoy outdoor, sailing, skiing, hiking, together with the family. So congratulations.
Yes, thank you so much, Ralph and EPMA. It's such an honor. It's such an honor to be part of the team that has received this award earlier. And I can see some of you just in front of me. Just as Ralph mentioned, I have really enjoyed all the cooperation activities with universities and institutes, sometimes competitors, system suppliers, equipment suppliers, and of course with our customers, the component manufacturers. And if we have been really lucky, then we have even had an end user on board. I'm looking forward to see more of this type of cooperation work in the future. So let's take the PM technology to the next level and have fun. I would like to thank the family I have, and I would like to thank the big powder family that we have here. Thank you.
Thank you.
Thank you, Ralph. Next award is the Keynote Paper Award. This year's Technical Program Committee has awarded 6 keynote papers, and each selected author will have an extended time slot in the respective session. New since last year, all awardees have the prize from EPMA. Namely, we have Dr. Sanz, Dr. Wimbert, Dr. Vives, Dr. Sigar, Dr. De Godenzi, Mr. Gopaluni. If all awardees can join me on stage, I hope you are in the room. At least some of them, yes. And so Suzanne and Alexander will also come on stage. Now we have to find who is who. If you want other on the floor. Thank you, ladies and gentlemen. Thanks for the chair.